A 4-pole 1200 RPM DC lap wound DC generator has 1520 conductors. If the flux per pole is 0.01 Weber, the EMF of the generator. So we know the EMF formula. EMF is equal to pi Pn by 60 into Z by A. Okay, so it is the lap winding in the sense A is equal to P. So A and P will be cancelled out and flux 0.01 and N is 1200 RPM given by 60 into number of conductors directly given. So very easy question. 60 ones, 62 zeros, 10 cancelled out, and this 0, this point, 2 points will be cancelled out. So 152 into 2, that is nothing but 304. So the answer is option C. So the answer is option C. Okay, just wait. Yes. Coming to the next question, guys. Two-pole wave-wound DC generator has 120 conductors in each parallel path. In each parallel path of its armature. If it is driven at 1200 RPM and excited to have 0.02 Weber per pole, the induced EMF would be dash. What will be the induced EMF? So same formula, EMF is equal to pi Pn by 60 into Z by A. It is a wave winding in the sense number of parallel paths are 2. Number of parallel paths are 2. Okay. So pi is 0.02, poles are 2, speed is 1200 RPM by 60 into number of conductors, 120 conductors in each parallel path. We have wave winding 2 parallel path means 120 conductors in each parallel path. 2 parallel path means 120 into 2, 240. So 240 conductors by parallel paths are again 2. So 2 to cancel out, 61, 62 zeros. Okay, this 0, and here 2 you will get. 2 into 2, 4. 4 into 24 is 96 volt. Coming to the next one. A 4-pole generator having lap wound armature winding has 51 slots. Each slot contains 20 conductors. What will be the voltage generated in the machine when driven at 1500 RPM, assuming the flux per pole is dash? I think already we have done this type of question. So the answer is option D. No need to discuss again. The EMF induced in a DC shunt generator is 230 volt. The armature resistance is 0.1 ohm. If the armature current is 200 amps, the terminal voltage. We know very well in case of generator, EMF induced first. So after that, terminal voltage and voltage drop is there. Okay, so this is the equation in generator. So here they are asking the terminal voltage. Terminal voltage is always less than that of the EMF. Okay, so from this equation, the terminal voltage is nothing but the generated EMF minus drop. Okay, so generated EMF 230 volts given, and IA is 200, RA is 0.1. That is 20. So 20 in the sense 210 volt. So the answer is option C. 210 volt. So the answer is option C. Coming to the next one, guys. Coming to the next question. DC shunt generator is supplying a load of 1.8 kilowatt at 200 volt. Its armature and field resistances are 0.4 and 200 ohms respectively. What is the generated EMF? What is the generated EMF? Generated EMF formula just now I have given terminal voltage plus IA RA. So we have terminal voltage 200 and armature resistance 0.4, but we don't have IA. So how to find out the IA in shunt? In case of shunt machine, IA is equal to, here it is a shunt field, It is the load current. It is the shunt field current. It is the RSH. This is the IA. So in case of shunt machine, IA is equal to IL plus ISH. So if you want to find out the ISH, shunt field current, voltage by RSH, terminal voltage by RSH. Here EMF is generated. So terminal voltage they have given 200 volt by RSH is nothing but 200 ohms, that is equal to 1. And what is the IL? Here power given as total power VL IL is equal to, or VT IL is equal to 1.8. So IL is equal to 1.8 kilowatt, that is 1800 by VT is nothing but 200, that is equal to 9 amps. So total IA is equal to now 9 plus 1. Okay, IL plus ISS, that is 10 amps, or 1 plus 10, whatever it may be. 10 amps. So it is a 10 amps, then substitute in the equation 200 plus IARA, 10 into 0.4, that is 40. Sorry, that is 4, 2 not. Okay, a simple idea here also, it is generator in the sense generated EMF always greater than the terminal voltage. So more than the 200. So we can eliminate these two. But we have two options, that is we need to calculate only. Okay. Coming to the next one. A 6-pole 50 kilowatt DC machine operating at 1180 RPM has generated EMF of 136.8 volt. The speed is reduced to 75% of its original value and the pole flux is double. The induced EMF will be dash. So here speed and flux are changes. We know very well EMF equation is pi Pn by 60 into Z by A. Here number of conductors, parallel path and also poles are constant. 60 also constant. So EMF is always proportional to pi into N. If the pi is doubled, okay, and the speed is 75% of the original speed, then what about the EMF? EMF is equal to pi is 2 pi and speed is 0.75 of the N. So EMF is proportional to 0.75 into 2, that is 1.5. 1.5 of the pi N, that is E2 is equal to 1.5 of the E1. So 1.5 times of the 136.8. Let us consider it is a 140, that is a 210. So less than 140, no, less than 210. So the answer is option C. Answer is option C. Okay, like that we have to go with the approximation method. And coming to the next one, in case of cumulatively compound DC generator is supplying 20 amps at 200 volt. Now if the series field winding is short circuited, the terminal voltage. This type of questions are very important, guys. Cumulative compound, the resultant is flux is equal to shunt field flux plus series field flux. Okay. So now if the series field winding is short circuit means almost it makes zero flux. So that is nothing but can say total flux, resultant flux is decreases. Okay. So whenever the resultant flux is decreases, then EMF also decreases. EMF also decreases. Why? Because EMF is proportional to the pi. So it will be less than that of 200 volt. Less than that of the 200 volt. Coming to the next one, same type of question in case of differentially compounded DC motor runs at full speed of 480 RPM. The series field winding is short circuited. Then what about the speed? Here they are asking about the motor. Okay. So differentially compound means here resultant flux is equal to pi SH minus pi SC. If it is open circuited or short circuited, it will be almost zero. That means if the negative part is zero, resultant flux is increases. And we know speed is inversely proportional to the flux. As flux increases, the speed will be decreases. Okay, the speed will be decreases. Speed is decreases means less than its full load speed. So the answer is option A. Less than its full load speed in the sense, answer is option A. Okay. A lap wound DC generator having 250 armature conductors runs at 1200 RPM. If the generated EMF is 200 volt, then the operating flux of the DC generator is dash. They are asking operating flux. And given armature conductors, speed, generated voltage, and all given, just asking the operating flux. So we can find out the operating flux from the generated EMF equation, 5Pn by 60 into Z by A. So we want only the flux. Generated EMF 200, and it is a lap wound. Lap wound in the sense A is equal to P. So we can cancel out this one. We need the flux. Speed given as 1200 by 60. Number of conductors are 250. Okay. So 60 ones, 62 zeros, 20 ones, 20 tens. This 0 cancel out. So that is pi is equal to 1 by 25 Weber. 1 by 25 in the sense, if you consider it is 125 force. 100 means 2 zeros, that is 0.04. 0.04 Weber. So the answer is option B. Okay, coming to the next question, guys. 0.04 Weber. Coming to the next question. An 8 volt 250 volt wave wound DC generator has 200 conductors. If the generator is to be lap wound for the same voltage, the number of conductors required. The number of conductors required. Here we can find this one by using the formula or by just understanding. Just understanding method is very easy, guys. All of you listen carefully. Initially they have given wave wound. Wave wound. So the number of conductors they have given 200. So in the wave wound, how many parallel path? 2 parallel path. So 200 conductors, 2 parallel path means number of conductors in each parallel path. Number of conductors in each parallel path is nothing but 100. 100 number of conductors in each parallel path. Okay. So if you can consider in the lap winding, to get the same EMF, the number of conductors required will be dash. Here, the number of conductors, if you want to get the same voltage and then here number of parallel paths are nothing but poles. So how many parallel paths? 8 parallel paths. So here we have to wound with 8 parallel paths. 5, 6, 7, 8. So each conductors each parallel path having 100 conductors. Here 8 parallel paths in the sense that is 800 conductors. So we require 800 conductors. Okay, we require 800 conductors for the same voltage. If to get the same voltage, if you want to wound into the lap winding, the number of parallel paths will be as per the poles. Okay, so each conductor, that is number of conductors in each parallel path is 100 means total 8 parallel paths are there. So the total conductors required will be 800. Or otherwise you can go with the formula, EMF equation formula. It is a lengthy method. EMF is equal to 5Pn by 60 into Z by A. Here you have to substitute all this. Okay, you have to substitute all this, and after that here you have to apply same EMF equation. 5Pn by 60 into Z by A. You need to find out the number of conductors. Okay, here you have to substitute in the wave winding A is equal to 2. Okay, and EMF value as 250 volts. Okay, and pi they have not given, and also N not given. So that means you have to find out the pi N, and poles given as 8. Okay, conductors given as 200. Okay, so 2 ones, 200s. 800 by 60. Okay, or this 1010 is cancelled out. So 80 by 60. So you will get pi N value. So you have to substitute that pi N value here to find out the Z. So EMF you have to take the same 250. Then you will get the answer. But it is the formula based method is lengthy. So just to go with the simple understanding method. Coming to the next question. The armature resistance of 220 volts DC machine has 0.5 ohms. If the full load armature current is 50 amps, what will be the induced EMF when the machine acts as generator and motor? So first of all, the machine is acting as a generator. We have to find out induced EMF. Generator induced EMF always higher, terminal voltage plus IA RA. Okay, So what is the terminal voltage? 200 volts given. IA, armature current, full load armature current is 50 and RA is given as 0.5. That is 225. We will get 225. So only one option is there. So directly you can give the answer without finding the motor. Okay. So in case of examinations, we have to think the smart. Whenever we got one, just we have to check with the options. No need to go for second one. Okay. And we don't want to waste the time. That is very important in competitive examinations. Second, in case of motor, the EMF is nothing but terminal voltage minus IA/RA drop. So terminal voltage is 200, IA/RA drop already here we have calculated 25. So that is 175. So the answer is B. Just for to know the things I have given. Okay, so the examination no need to find out in case of motor. In a 6-pole DC generator, the ratio of induced EMF in lap winding and wave winding. In lap winding and wave winding. So generally we know very well, in case of lap winding, the voltage ratio is always somewhat of less. Okay, lap winding is used for low voltage and wave winding is used for high voltage, correct? Wave winding is used for high voltage. So that means always voltage in case of lap is less than voltage in case of wave. We have to check like this. Any options are satisfy this one. Here two options are there. That means we have to find out answer only. Okay. If only one answer is satisfied, directly you can give the answer. Okay. And here the very important thing, as per the EMF equation, pi Pn by 60 into Z by A. So EMF is always inversely proportional to the parallel path. Inversely proportional to the parallel path. Okay, and here in case we can say E lap by E wave is equal to, inversely proportional means A wave by A lap. A wave by A lap. Okay. So here induced EMF in lap winding and wave winding. So lap by wave is nothing but A wave, number of parallel path in the wave, 2, lap winding 6. Okay, so that is 1 by 3. So that means E ratio EL is to EW is equal to 1 is to 3. So the answer is option B. 1 is to 3, answer is option B. Okay, and also current always proportional to number of parallel path. Current always proportional to number of parallel path. And one more important, here it is inversely proportional, it is directly proportional, and but powers are always equal. Power in lap winding is equal to power in wave winding. Why? Because in lap winding we can say current is more, EMF is less. Wave winding, EMF is more, current is less. So the product will be almost equal. Okay, the product is almost equal. So here answer is option B. Coming to the next question, very important one this. And a 230 volts DC series generator is driven at its rated speed. The no load voltage across the armature terminals would be dash. We know very well, in case of self-excited generator, at no load also there is a small some residual flux is there. Due to that, a small voltage is developed. That voltage 6 volt to 12 volts. So here less voltage, given only one option. So directly you can give the answer as option D. Coming to the next one, 4-pole DC generator is running at 1500 RPM. The frequency of current in armature winding. Armature winding always we have the AC supply. AC supply in the sense it has a frequency. Okay, that is just like synchronous speed, ns is equal to 120 f by p. So if you want frequency, we have to substitute the speed 120 into frequency by poles. Number of poles are 4 ones, 4 3 zeros, 30 ones, 30 50s. So frequency is equal to 50 hertz. So that's, if you have not subscribed the channel, please click on subscribe button and also please share the information to all your friends. A simple method of increasing the voltage of DC generator. How we can increase the voltage of the DC generator? So if you can consider EMF pi Pn by 60 into Z by A. Okay. So once the machine has designed, then Z is constant, conductors, parallel path are constant, poles are constant, 60 is a constant. So EMF is proportional to pi into N. Here if you want to increase the pi, there is a saturation problem. There is a saturation problem. Flux, if you increase the field current, flux may be increases up to certain point only. After that, if you increase the field current also, flux will be constant only. But we can simply increase the speed. So by increasing the speed of rotation, we can simply increase the EMF. Then as the EMF increases, terminal voltage also increases. So increase the speed of rotation. Increase the speed of rotation. Okay. And coming to the next one, if the flux per pole of DC generator is off, but its speed is double, then what happened to the EMF? Just now I have given that EMF is proportional to pi into N. Here they have given flux is going to be off, as the flux is going to be off and speed is doubled. Then this to cancel out. Again, EMF also is nothing but pi N only. So that is nothing but constant, same. So remains the same. Coming to the next question, guys. If the number of poles in a wave-wound DC generator is double, then the generated EMF will be dash. So here they are asking about in case of wave winding, parallel path are 2, that is a fixed, and EMF is equal to 5Pn by 60 into Z by A. A is nothing but 2. Okay. So here the number of poles are double. The poles are double. Then what about the EMF, guys? 2P into N by 60 into Z by 2. Okay. So that means EMF is equal to, if you common this to 5Pn by 60 into Z by 2, that is EMF of the previous. So EMF, if you can consider EMF 2, it will be 2 times of the EMF. So that means it will becomes double. Becomes a double. Okay, a very easy question. Coming to the next one, guys. If the number of poles in a lap wound generator be double, then what happened to the generated EMF? In case of lap wound, A is equal to P. So EMF equation 5Pn by 60 into Z by A. So A is nothing but P now. So this one cancel out. So EMF is equal to pi n by 60 into Z. So it is no P term, no poles term. So if you increase the poles or decrease the poles, it may not be, depends upon the poles. So can say it remains constant. It remains constant. Okay, so the answer is option D. Coming to the next question, guys. A 4-pole lap wound DC generator has a developed power of P watt and voltage of E volt. One brush of the machine is removed as it worn out. If the machine operates with the remaining brushes, the developed voltage and power that can be obtained from the machine are dash. That can be obtained from the machine are dash. Here it is a lap wound first of all, and number of parallel path is equal to number of poles, that is 4 poles. So and brushes are also will be 4 only, because of brushes depends upon the number of parallel path. So parallel path, 4 parallel path, 1, 2, 3, consider as 4 parallel path. Okay, and if it is a 4 parallel path, then what is the current? Current will be divided as Ia by 4 in each parallel path. Here Ia by 4, here Ia by 4, the brush indication. Here Ia by 4, here Ia by 4. Now they have given one of the brush is worn out. If any of the one brush is worn out, for example, if this brush is worn out, okay, if this brush is worn out, then it is an open circuit, it is open circuit. Then these two paths only having the, closed circuit, then current will be Ia by 4 plus Ia by 4, that is equal to Ia by 2 of the current. And in case of if we have any number of parallel path, if 2 are removed, only if we have the 2, then also the EMF will be same across the parallel. Okay, so in parallel EMF will be same. So that means here the answer is EMF is the same and current will becomes current by 2. Okay, then what will be the power? E into Ia. So E into Ia by 2. So that means you will get power will becomes P by 2. As current is off, power also will becomes off. So E and P by 2. E and P by 2. So the answer is option D. So the answer is option D. Okay. So if any one brushes is worn out as it is removed, the other two will be open circuited. The current will become IA by 2. So then power will become V by 2. Coming to the next question. Same question, a 4-pole lap-on DC generator has developed a power of P watts and voltage of E volts. The two adjacent brushes of the machine are removed as they are worn out. If the machine operates with remaining brushes, the developed voltage and power that can be obtained from the machine are dash. So same 4 brushes because of 4 poles of that is 4 parallel path. Okay, so we have 4 parallel path. Here what they have given, the two adjacent brushes of the machine are removed. Two adjacent brushes. Any two adjacent brushes. So now I am removing two adjacent. This is the 1. This is the 2. So yes. So it is the open circuited. This path also open circuited. This path also open circuited. This path only closed circuit. Then current will becomes IA by 4. And in parallel path, if any number of parallel paths are open circuit also, the EMF is same. EMF is same. Then power will becomes P by 4. As current is 1 by 4, power will becomes P by 4. E comma P by 4. E comma P by 4. For example, if opposite brushes are removed. If opposite brushes are removed, this brush and this brush, then all will be open circuited. Current is 0, then power will be 0. Power will be 0. Coming to the next question. In a small DC machine, carbon brushes are preferred because of dash. We have already learned about this carbon brushes advantages. Here they have asking again in different question manner. Carbon brushes are preferred because of more resistance. Yes, carbon is a non-metal, it is a more resistance. One is correct. Wherever there is a one, that is correct. Here one is not there, we can eliminate this one. Higher thermal stability. Yes, it has high operating temperature, so high thermal stability is also correct. Wherever two, that is correct. Okay, so wherever there is 1 and 2, that is correct. So it is 1 and 2 is not there, so we can eliminate this one. Okay, and self lubricating property, yes, because it is a non-metal and it is a soft in nature, self lubricating. And less voltage drop across the brushes than copper brushes. No, it is not correct. Okay, so why? Because here carbon having high resistance. Already here we have discussed resistance is high. So as resistance is high means voltage drop also higher than the copper brushes. So 4 is wrong. Wherever there is a 4, that is wrong. So can give the answer as 1, 2, 3 only. 1, 2, 3 only. Coming to the next question, guys. For a DC machine, shunt resistance and armature resistances values are dash. Shunt resistance and armature resistance. For example, let us take a shunt machine. Here we have the armature resistance. This is the shunt field resistance. Yes. Okay. So they have given machine. It may be a generator or it may be a motor. For example, if it can consider as a generator, this is the IA, this is the IL, this is the ISH. Generally, if the IA is 100%, IL has to be nearly 95% and ISH has to be 5 to 6%. That means if you want to bifurcate the just 5% of the current, what happened to what is the resistance we have to take? If the resistance is more, then only less current is flowing. Okay, and more current will be flowing through the load. So that's why RSH has to be high always. Okay, and IA is always more. To get the load drop, RA must be less. To get the load drop, RA must be less. So always armature resistance is like less than 1 ohm. This RSH is like a 200, 300 ohms like that. Okay, so RA is always less. RSH is higher. So they are asking shunt resistance high, armature resistance low, high and low. So the answer is option C. Okay, high and low. So the answer is option C. Coming to the next question. In a compound DC motor, the shunt field winding as compared to the series field winding will have dash. In compound DC motor, shunt field winding as compared to series field winding. Let us take a short shunt or long shunt, whatever it may be. Here I am taking the example as long shunt. Here they have given the motor. So this is the load current, this is the armature current, and this is the shunt field current. Armature current is also equal to series field current. Okay, so here armature resistance we have. So IA has to be more, correct? So center wheel always just to 5 to 6% only. So IA has 95% nearly. So as IA is more means we have to make the series field resistance must be less. Okay, series field resistance must be less. As RS is less means R is equal to rho L by A. If you want to get low resistance, area must be higher. Area must be higher, and ISH has to be less means RSH has to be more. To get the RSH has to be more, area will be less. Okay, so area will be less, and also to get the more flux, then turns will be more. I'll take more turns. So that means here more turns are required to get the more flux and smaller cross section area. Smaller cross section area. Here the series field winding, less turns and thick area, thick cross section. Okay, this is in case of compound motor. Coming to the next question. Field winding of DC shunt machine carries dash of the rated current. In last two questions, I have already given the field current limited to 5 to 6%. So here 5 to 6 not given, 2 to 5 given. So I have select the 2 to 5. Okay. Okay, students, if you feel my classes are useful for you, please click on subscribe button and also please share the information to all your friends. Okay. And also if you want download the PDF, you can get from suneelengineeringacademy.com. I will give the links in the description box. You can download from that. So first of all, it is in the lap wind. In that case, the resistance of the lap is 0.05 ohm. If it is converted into wave, then what will be the resistance? What will be the resistance? We have the direct formula: armature resistance in wave winding by armature resistance in lap winding is equal to we will get IL by IW whole square or AL by AW whole square. Okay, this is the direct formula. How we are getting this one? Let us take that. So we know very well EMF is inversely proportional to the parallel path. EMF is equal to pi p n by 60 into Z by A. So inversely proportional with A. So from this one we can say that E lap by E wave is equal to inversely proportional na? That means A wave by A lap. A wave by A lap in the sense current is always proportional to the parallel path. So I wave by I lap. Okay, current is proportional to the parallel path. So that's why AW by L is equal to IW by IL. And whatever it may be, the power will be constant. So in all the cases, the power is constant. Power in lap winding is equal to power in wave winding. Okay. So here IL square RAL is equal to IW square RAW. So if you want RAW by RAL is equal to IL by IW whole square na. IL by IW square. IL by IW is nothing but AL by AW. AL by AW. Okay, AL by AW whole square. So that means number of parallel path in lap winding, number of parallel path in lap winding, number of poles, that is 6. In wave winding, 2 whole square, that is 3 by 2 whole, sorry, 6 by 2 means 3 square, that is 9. Okay, so then RAW is equal to 9 times of the RAL, that is 9 times of the 0.05, that is 0.45. So the answer is option A. Okay, so in the examinations no need to derive all this, just you have to remember that RAW by RAL is equal to AL by AW whole square. Okay, so if you substitute that formula directly you can get the answer. Coming to the next question, the series field of a short shunt DC motor is excited by dash. Series field of a short shunt DC motor is excited by dash. What is the short shunt and long shunt? If the shunt winding is connected or field winding is connected as short, then that is a short shunt. If it is connected as long, then you can say that is a long shunt. Okay. So let us take a short shunt. So they have given the motor. For motor, we are giving the supply. So I am giving the supply to this motor. Okay. I am giving the supply to this motor. Here, in case of this compound motor, here we have the series field winding. This is the series field winding. If the shunt field winding is connected short, that means only parallel to the or only shunt to the armature, then we can say it is a short shunt. In case of long shunt, the same thing in the long shunt. Here we have the series field winding. We have given the supply. If the shunt field winding is connected across total armature with a series winding, armature and also series winding, then we can say that is a long shunt. So here we are connecting shunt as long, here we are connecting shunt as short. Okay, that is only. So here IL, the load current, here ISC is equal to armature current. Here IL is equal to ISC, both are series. So IL is equal to ISC. Okay, and here ISC will be divided as IA. So what is the current flowing through the armature is IA plus this is considered as ISH. But here IA is equal to ISC and IL is equal to IA plus ISH. Okay, so that means in the short shunt, the series field winding is excited by load current. It is excited by armature current. So armature current in case of long shunt. Armature current in terms of long shunt. Okay, coming to the next one. DC generator, when driven at its rated speed, it is found to be not generating, guys. Not generating any voltage. Which are the following would account for this? It is not generating means it is not following the conditions of buildup of voltage. What are the conditions of buildup of voltage? It must be having residual magnetism. Here no residual magnetism means yes, not generating, correct only. The connections of the field winding must be proper to get the buildup of the voltage. Here not proper means not generated, correct. The resistance generally to get the buildup of voltage, resistance must be less. Here resistance is greater given, so it is also wrong. So that it is also not buildup of voltage, correct. Load resistance must be somewhat of more than the critical resistance, that is condition. Here less given, less means not generated, it is also correct. So 1, 2, 3, 4, all are correct. So can give the answer as option D. So for generating, we require all opposite. Okay, but here not generating given, options are also not given. So that means all answers are correct. So the answer is option D. DC shunt generator when driven without connecting field winding shows an open circuit terminal voltage of 12 volts. When field winding is connected and excited, the voltage drops to 0. Whenever the voltage is going to be dropped 0 from 12 volts to 0 means if the field winding connections are opposite. Whenever the field winding connections are opposite, we are getting the reversal in the voltage. So that means the total flux will become 0. Whenever the total flux will become 0, then no EMF will be produced. So the main reason, the most probable reason is nothing but field winding has got wrongly connected. Whenever the field winding has got wrongly connected, now EMF is going to be 0, then flux, resultant flux is 0, then EMF is also 0. In this case, whenever the field flux, whenever this total flux becomes 0, then you don't have residual magnetism. So then again we have to get some residual magnetism. For that, what we are doing? We are doing the method is called as field flashing. We are connected a DC supply for a small amount of the time, then it will be again regain its residual magnetism. Then again it will be ready to build up the voltage. Field flash or flashing of the field is actually means, what is the flashing of the field? Whenever the residual magnetism totally is 0 because of the field connections are wrongly connected, in that case we are going with the field flashing method, that is creating residual magnetism by a DC source. The residual magnetism of a self-excited DC generator is lost to build up its EMF again. So then again we have to excite it with a DC supply. So the answer is option D. DC shunt generator running at 800 RPM, its critical resistance is 200 ohms. If the speed increases to 1000 RPM, then its critical resistance is dash. Generally, the speed is calculated at a particular resistance. Our resistance will be calculated at particular speed. Okay, so these two are indirectly proportional. The critical resistance is directly proportional to the speed. If the speed varies, critical resistance also varies. Okay, so it is varies from 800 to 1000 means it will be varies from 200 to 250. RC2 by RC1 is equal to N2 by N1. If you substitute that one, you will get 250. Coming to the next one. The output of voltage of DC generator, the ripple effects can be reduced by increasing the dash. If you want increase the, if you want reduce the ripple effect, we have to increase the number of commutator segments. Number of commutator segments. If you use the more number of commutator segments, then you will get more uniform wave. So number of commutator segments are equal to number of coils. So here number of armature coils. If you increase the number of armature coils, you can get increment. You can get the ripple free. For example, if number of commutator segments are less, then you will get the waveform is like this. If you increase the commutator segments or increases, then you will get like this, somewhat of more uniform wave. Okay, so if you increase the number of commutator segments, number of coils will be increased, so then you will get more uniform waveform. Okay, and coming to the next one, a 6-pole lamp-on DC machine armature has 720 conductors and it draws 50 amps from the supply. What is the flux distribution produced by armature reaction per pole? So here armature turns per pole we need to find out. Armature turns per pole we need to find out. What is the formula for armature turns per pole? ZIA by 2AP. Na? Here which winding? Lap winding. So A is equal to P. So that means number of conductors, 720 conductors, and armature current is like a 50 amps, and 2 into number of parallel path is equal to poles only 6, and poles are also 6. Okay, so then you can find out this one. 6 into 6, 36, 36, 2 zeros, 2 ones, 2 tens, that is 500. 500 we have two options, this one and this one. And here you can say armature reaction per pole, armature AD. AD is nothing but ampere turns. Ampere turns is nothing but you can say MMF. So MMF, armature MMF is always triangular in shape. Triangular in shape. So triangular in the sense, so can give the answer as options. Okay, triangular in shape. Coming to the next one, the DC machine, the armature reaction MMF. Here armature MMF must be stationary with respect to field MMF. Okay, so to get the production of unidirectional torque, both MMFs stationary, that is stator and the rotor MMFs must be stationary with respect to each other. Okay, so here armature is a rotating part, it will be this MMF is stationary with respect to stationary part. Stationary part means stator, so it is stationary with respect to stator. Okay, and rotating with respect to armature, stationary with respect to stator and rotating with respect to armature in the reverse direction. Okay, the armature MMF of a DC machine has, already I have given armature MMF, it is in the triangular shape. Triangular shape we have one option, two options, and it is stationary with respect to stator and rotating with respect to armature. Okay, just now I have given, so the answer is option D. So the shape of main field of flux distribution. For example, if you have, just for example, I have taken the poles in horizontal manner, north pole, south pole. Okay, so here air gap we have, here some air gap we have. So if we have air gap means reluctance is more. If the reluctance is more, the flux distribution will be less. Okay, flux is inversely proportional to the reluctance. Here under the pole, air gap is minimum. Okay, so minimum means you will get maximum flux distribution, so it will be increases towards that minimum air gap. Again air gap will be maximum, so you will get like this. Okay, that means you are getting trapezoidal form, main field flux trapezoidal form. So this is also called as flat taped or trapezoid. Okay, under the pole we are getting constant flux. Here air gap is more, as air gap is more, flux will be less. Why? Because flux is inversely proportional to the reluctance. So that's why you are getting flat tapped wave. In DC machine, the space distribution of air gap flux density
at a no load. So flux density is equal to V is equal to flux by unit area. So it is directly proportional to the flux. Okay. But in case of no load, they are asking. In case of no load, we have only main field flux. Only main field flux. Armature flux is absent. Okay, because of that is a no load, so no armature flux. Only main field flux is there. So only main field flux is there, then flux density also having the same waveform. So flux density also having flat tape. Flat tape. So the answer is option C. Flat tape. So the answer is option C. If we have armature reaction, in case of loaded case, the same question, area of flux density wave at loaded cases. In case of loaded cases, we have main field flux and also armature flux. So if we have some magnetizing effect, in that case we will get the curve instead of flat tape, you are getting some peaky wave. Some peaky wave. So flux density at a loaded case, it is the peaky wave. So the answer is option C. So the answer is option C. Coming to the next question, guys. In the commutation process, it is a dash. What is the commutation? It is nothing but reversal of the current is called as the commutation. So the answer is option B. In DC machine, armature is always on the rotor, unlike AC machine, where it could be either on the stator or rotor. So in case of AC machine, we can use on both stator or rotor. Okay. But in case of DC machine, we have to fix the rotor, the armature on the rotor only. Why? Because we have to get rotational armature. Why rotational armature? Then only commutation action takes place. Then only commutation possible. If it is a rotating, then only commutation is possible. Reversal of the current takes place. Okay. So otherwise, what will happen? Commutation action will be failed. That means we cannot convert AC to DC. Inside the armature always we have the AC now. If we want convert AC to DC, we require, this is the rotation. Why? Because this commutator is the rotational rectifier, mechanical rectifier. Okay, so it can convert AC to DC. So otherwise what will happen? Commutation action would be failed. In case of AC machine, no need of commutation, no need of converting of AC to DC. So that's why anything will be possible. Okay. Coming to the next one. Open type slots are used in DC machine armature because of it. So if you use the open type slot, then what will happen? Open type slot is open. Whenever the slot is open, or you can also represent like this. Okay, so if the slot is open, then it reduces the reactance EMF and also aids the commutation. Why? Because open type slots high resistance. So high resistance means commutation will be improved. Less sparking in the sense reactance EMF will be also reduced. So the answer is option A. Coming to the next one, function of interpoles in DC machine is 2 dash. What is the function of interpoles in DC machine is 2 dash? Reduce field winding heating, improve commutation, compensate for air gap variation, reduce the losses. Interpoles having two purpose. One is it improves the commutation. Second one, it reduces the reactance voltage. Okay, it reduces the reactance voltage. And also one more thing, cross magnetization effect also cross magnetization effect also decreases. Why? Because for example, if you can consider, it is the armature. For example, if it is the, let us take just wait. Yeah. So we have to take anyone as a reference, or if you can consider it is the main field MMF. Armature MMF is always like a cross if it is the armature MMF. Okay, if it is the armature MMF. That means here we are getting cross magnetization effect. So to reduce the cross magnetization effect, the resultant will be you are getting this one, so cross magnetization effect. So if you want to reduce this cross magnetization effect, we have to eliminate this MMF due to armature reaction. So for that, we have to take opposite side of the MMF, that is created by interpoles. So this one is going to be cancelled out. So then only our main field flux is there. Then cross magnetization effect will be somewhat of reduced. So cross magnetization effect will be reduced and improves the commutation and reduce the reactance voltage. Why it reduces the reactance voltage? It generates some counter EMF to the reactance voltage, so that both will be nullified. So the answer is options. Interpoles are used in dash. Interpoles are used in dash. Interpoles may be used in both lap and wave windings. It is not restricted to only one winding. It is for both lap and wave winding machines. Interpole winding is connected in dash. Interpole winding is connected in dash. Interpole winding is connected in series with the armature. In series with the armature. And compensating winding is connected dash. This compensating winding also always in series with the armature. So both are always in series with the armature. Then only they will be generate the MMF opposite to the armature reaction MMF. Okay, so that's why both are always connected in series with the armature. Okay, and the current flowing in the compensating winding will be opposite to that of the armature winding. Okay, so then only it will provides the counter flux, then armature flux will be reduced. Okay, yes, here they have given the question. Direction of the current in the compensating winding is dash to the direction of the current in the armature conductor. It is exactly opposite. Then only that armature flux will be neglected. That reaction also neglected. Okay. And coming to the primary reason for providing compensating winding. So for compensating winding also we can reduce the cross magnetization effect, and also it will helps on commutation. Okay, so it neutralizes the cross magnetization effect. As cross magnetization effect is reduces, automatically sparking is reduces. Sparking reduces means commutation improves. Okay, coming to the next question. In a 10-pole lap-wound DC generator, the number of active armature conductors per pole is 50. The number of compensating conductors per pole. This compensating conductors per pole is also equal to number of conductors per pole. Number of conductors per pole. So conductors per pole is 50 per pole. Conductors per pole. So that is nothing but 50 by 10. That is equal to 5. So the answer is option E. Active number of armature conductors per pole. Okay. So Z by P. That is 5. Okay, students, we will discuss the remaining questions in the next session. If you have not subscribed the channel, please click on subscribe button, and also please share the information to all your friends. And if you want to download the PDF, you can download from SuneelEngineeringAcademy.com. Okay, thank you so much, students. All of you take care. Bye.